The population of a certain animal being researched by environmentalists has been decreasing substantially. Biologists tracking the species have determined the following data set to represent the remaining animals. So in the year 2010, we had this many, 2011 was this many, 2012 was, you can get the drift. Okay, assuming the population continues at the same rate, and that would be a percentage rate, what function would represent the population, A of t, in the year t, where t is the number of years after the year 2010? Years after 2010. So first of all, we need to figure out what we're really dealing with here. Well, we're dealing with the population of something, and it is decreasing clearly at some rate, a percentage rate. It's not necessarily a decay factor in this practical sense so much as it is a percentage. We don't know it, but it is going to be a situation like this. 1 plus or minus. Let's go ahead and put the minus because that's what we're dealing with, to the t. Okay, now t is the number of years after the year 2010. So if you want to really put this in practical terms, in this really t is equal to 0. So time starts counting here, which really means time is 1 here, and time is 2 here, and time is 3 here, and time is 4 here. Okay, and we don't need all that data. There's something really interesting we are going to do with it though. So let's actually figure out what r is because we don't know r. Let's find that. That's going to come in handy. So let's figure out, let's just use this piece right here, and we're going to find out what r is to the best of our ability. Actually, that won't help us find out what r is. But I'm going to plug in 40,000 for p. And yeah, that won't help me find out what r. I need another set of data points. So I'm going to use 2011 and 30,000. So 30 right here. And that means I have 1 minus r, and we're going to raise it to the t power, which is 1. And this is going to be really easy to do, trust me. Okay, so we're going to divide 30,000 by 40,000, and all those zeros divide out, and you're left with 3/4, which is 0.75. So 1 minus r to the 1 is 0.75, and now it's going to get really, really easy. Really easy. So we're going to subtract 1 from both sides. And that's going to give me negative 0.25, and that's equal to negative r. And so r equals 0.25. And that's great. That means r is 25%. Okay, now I still need the population A of t in the year t. So here's where things get fun. I had just a little bit of a brain freeze a second ago where I was like, we'll just use this point. Well, I had to have 2 points because I had to have a starting point and then another point afterwards. So 40,000 to 30,000, and it's going to be at the same rate. So let me kind of write the final answer. I'm going to put it here in red and make it stand out. The population of this particular animal is always 40,000 times, and I don't want to waste your time putting 1 minus 0.25, and then we'll be like, oh, 1 minus 0.25, and then that's 0.75. We actually already knew that here. We could have stopped right here and gotten everything we needed. Why didn't we? We were having so much fun. And then there we go. That's our formula. I want to make sure it works, actually. So let's, well, make sure it works. Let's do it. I'm going to type 40,000, and I'm going to get 0.75, which it makes sense. This is 1 minus 25%, so it'd be 75%. 75% of the animals remain of this species from year to year. That's tragic. Raise it to the x. Okay, so far so good. 0, 1, 2, 22,500. 3, 18, 16, 875. 4, 12, 656. Yeah, it works. It works. That was it.